Bismillahirrahmanirrahim. Today we will talk about partial derivatives. Before this, we had studied derivatives in which we have one dependent variable, one is independent variable. But here in partial derivative, we have more than one independent variable. For example, this is dependent variable profit. The profit depend on the other variable. But here we have two variables. One is x, it's independent variable. One is y, it is also independent variable. Those variable, those equation which have two or more than two independent variable, then we use partial derivatives. So in simple words, the profit is not made from only one variable. So we are selling two kinds of variable. We are selling two kinds of things. For example, this is mobile and the another is laptop. So the combinedly mobile and laptop we are selling, combinedly they give us some profit. But now we are going to find how many mobile do we sell, how many computer do we sell. So this is partial derivatives. So here we have an equation in which we are going to find the profit, but the equation contain two independent variable. One is x, one is y. So now we will use partial derivatives. Partial derivatives, we use this simple for partial derivatives, and this is the profit divided by partial derivatives of x. When we are finding the derivatives of x, partial x, so we will mention only those which contain x. So this contain x, this contain x, but the other do not contain x. So we are taking value from only those which contain x. Here we have x, so the derivative of this portion is 80 only. And this we use power rule for this. Minus into plus minus, 2 2s are 4, and we have x. And here the x will be removed, only y will be taken from here. So this is equation 1. Now we will find the partial derivatives of y. So this is the profit divided by partial derivative of y. So now we will mentioning those variable which contain y. Here we have y, we have y here, we have y here. So from here the y will be removed and we are mentioning only minus x. Here minus into plus minus, 2 3s are 6, y. Here is y square and the derivatives of y square is only y, plus 100. This is equation 2. Now we will rearrange these equation. For example, I will write minus 4x minus y plus 80. It's up to you. You want to write 80 here, but just I want to write minus 4x minus y, and I mention the constant at the end. So it is not necessary. If you want to write 80 in the front, no problem. So in the next step, you should write the variable like x component will be written down the under the x. So minus x, here is minus 6y, and here we have 100. So constant below the constant, y variable below the y variable, x below the x variable. So now we are going to remove one of the variable from it. Let's say I want to remove this variable. So I will take the coefficient of it and multiply with this portion. So this is minus 4 and I will multiply with this portion. So minus x minus 6y plus 100. Now the sign will be changed. Here we have minus into minus, it will be plus, and 4x. Minus into minus plus, 4 6 are 24y, and here we have minus 400. So now this equation 3, now we will add this equation with those equation from where we have take the coefficient. So this equation will be added with equation 3. So I will again write the x portion under x, y portion under y, and constant under constant. So here we have minus 4x plus minus y, here is minus y, and we have plus 80. Now we will add it, so they will cancel with each other. Plus and minus, they will cancel with each other. So here we have 24 and we have one coefficient. So 24 minus 1, it will be equal to 23. From here, from 400 we will minus 80. So we will mention the sign of the bigger symbol, bigger figure. So we have 320 and we will write minus symbol because the bigger number have minus symbol, is equal to 0. Now we can find the value of y. So we will transfer this to the another side. So 23y is equal to, this is minus 320, it will be plus 320 when we shift from the other side of the equal. So we don't need 23 here, and we will dividing 23 on both sides. We need only y. So the value of y is equal to, this value will be divided by this. So it will be equal to 13.92. So this is the value of y. Now we will put the value of y in the above equation. If you want to put in equation 1 or in equation 2, no problem. So now I am going to put here in equation 1. So 80 minus 4x minus y. Instead of y, I will write the value of y. So the value of y is 13.92. 13.92 is equal to 0. Now we will subtract, this is constant and this is also constant. We will subtract this value from the 80. So minus 4 is remaining, and when we are subtracting this value from this, so it will be equal to plus, how much it will be equal? It will be equal to, wait a minute, it is equal to 6.08 is equal to 0. Now I am going to transfer the minus variable to another side. So plus 66 on position and I will transfer this value to the other side. So it is minus 4, it will be equal to plus 4. So now it is 4x. We need only x, so divide by 4 on both sides. This will cancel with each other, only x is remaining, and when we are dividing this value by 4, it will be equal to 16.52. So now we found both. We found x, we also found y. The third step is minimize and maximize. Now we are going to find minimize and maximize. So we are going to second order derivatives. So this is partial. We are going to take the second order derivatives of these both equation. Okay. We are writing 2 here because it is second order derivatives, and partial of x square here. So when we are taking the derivatives of this equation, when this is 80, this is constant, and when we take the derivative of the constant, so it is 0, we don't write to mention. So here we have minus 4, we do not write x because in derivative the variable which have power 1, it will be removed. So we don't need y here because this is the portion of x. So in this is the value of x here. Now we will find the derivatives of second derivatives of y. So second derivatives partial to profit and y square. So now we are mentioning here we don't need this because it is x. We are only mentioning x y variable here. So y variable only minus 6 is available here. Y will be removed because we are taking the derivatives. So the value of it is equal to minus 6. So both is maximum because it is minus, the result is minus. So it is maximum profit. It is also maximum profit. So now we are putting the value of x and the value of y in this equation. We will find the whole profit. So this is the partial derivatives.